Welcome back students to our new learning platform Catalyst for IIT JEE. I am Atanu from IIT Madras and today we are going to start our new lecture series on chemical kinetics. So this is a chapter from class 12 and this is a very important chapter for JEE Main, Advanced, NEET and as well as your board exam. So this lecture 1 is about the basic concepts on chemical kinetics. So if you have not subscribed us yet, please do subscribe and also hit the bell icon so that you don't miss a single video from our channel. We are also on Instagram now, so if you are active, please follow us there also. So the link for Instagram is provided in the description below. Now in this chapter, chemical kinetics, what are we going to cover? First, the rate of a chemical reaction. What is the rate of a chemical reaction? Then how do we mathematically express the rate of a reaction? Then we are going to cover the molecularity and order of reaction. Also we are going to learn about some unit measurements. Then integrated rate equations for the 0 and first order reactions which are in your syllabus, but for higher order like second order, third order reactions, you don't have those things in your syllabus. Now what are the factors that affect the reaction rate? Okay, and at last I'll talk about the collision theory. Please remember these all are in your basic concept lectures. For advanced we have a different things to cover. Okay, so these two parts I will cover in my lecture 1 and this part I will cover in my lecture 2, then lecture 3 and then lecture 4. So what is chemical kinetics? So chemical, as a chemistry student, you all know that chemical means a substance or a compound. Okay. Now, what do you mean by kinetics? So kinetics is the word related to motion. So what is motion? Motion you have learned in physics. So motion means movement. What is movement? Now, as you can see here, this person, okay, let me switch on the laser pointer first. Okay, so as you can see that this man is running straight from here to this direction. So this motion is called, this motion or movement is called rectilinear motion. Now the clock is rotating like this. So this is called circular motion. When a football is rolling on a ground, the motion is called rotational motion. And for a pendulum, this motion is called periodic motion. Now, in all these motions, what you will see, that you will see a change in position with time. As for example, in this clock, the hand of this clock was initially at this position, but after some time it moved to this position. So there is a change in position and it takes some time. So for chemical species, what we are going to talk about is the change in concentration with time. So in chemical kinetics, so in the term kinetics, the time must be associated and also the change in concentration must be associated within it. Now, why do we need to study this chapter chemical kinetics? So this is a very basic and important question for all the chapters. So if I ask some students that why are you interested to study this chemical kinetics, they will obviously answer okay, we will get some marks from our exam. Yes, that's definitely true, but there are bigger goals than that. Yes, let us take this example of rusting. So this is a very common phenomenon to you. This is a rusting of a machine, this is your rusting on toolkit, and this is your chain, and this is a clean new chain, and this is after rusting. So if we want to stop this rusting, why do you want to stop this rusting? Because of this rusting, many machines go bad and companies face a lot of problems in this. So they need to stop this rusting process. So to stop this rusting process, we need to understand first what is this rusting process. So in terms of chemistry, it is nothing but a chemical reaction. So iron reacts with oxygen in presence of moisture, and it turns into ferric oxide, which is Fe2O3, and water is associated with this ferric oxide, which is called rust. And if you want to stop this rusting, you need to understand this reaction very precisely. You need to understand the mechanism, you need to understand the rate, how fast this reaction is, and also you need to understand what are the factors that affect this reaction rate. So to prevent these processes like rusting, we need to understand the rate of a reaction. So for that we need to study this chemical kinetics. Now let us talk about the rate of a chemical reaction in detail. As I mentioned before, that rate of a reaction is the speed of a reaction. Now speed cannot be negative, right? So rate of a reaction also cannot be negative. Please take a note of this point, that rate of a reaction is always a positive number. Now rate or speed means how fast the concentration of the substances, that means your reactants or products, are going to change with time. Well, so based on the rate of reactions, there are different type of chemical reactions: instantaneous reactions, moderate reactions, and slow reactions. So for slow reactions, it takes a long time to complete the reactions, whereas for instantaneous reactions, it takes very short time to complete the reactions. Now for moderate reactions, it falls in between instantaneous reactions and slow reactions. Let us look at some examples of these three types of reactions. Now precipitation of silver chloride is very common to your standard, where you mix silver nitrate solution with a chloride source. Here it is HCl, and you see white precipitation of silver chloride. So this precipitation occurs instantaneously, and this is a very good example of instantaneous reactions. Now this molecule is rhodopsin molecule. When a light falls on this molecule, there is a photoisomerization. You see the cis trans isomerization. We will discuss this isomerization in detail in stereochemistry classes, and this isomerization is the main reason of our vision. Okay, so this is also a good example of instantaneous reactions. Now moderate reactions, there are many moderate reactions, but hydrolysis of ester, acid base reactions, any coupling reactions like CC coupling reactions are most common of it. Now rusting of iron is a good example of slow reactions. Also radioactive decay is a good example of slow reaction. Now if you mix nitrogen and hydrogen in a chamber and wait for 1 year to get ammonia, this is not going to happen, because the production of ammonia, this reaction is very slow reaction. Also the conversion of coal to diamond is a good example of slow reaction. Now in this chapter, moderate reactions are of main interest because these reactions are easy to study. So we are going to mainly focus on these moderate reactions for to understand the chemical reactions. Now to see the development of these chemical kinetics, one must mention that Peter Weig and Goldberg developed the chemical kinetics in 1864. They provided the law of mass action. So what is this law of mass action? It says that the rate of an elementary reaction is proportional to the product of the concentrations of the participating molecules. If you consider these reactions, from A to B, where A is your reactant and B is your product. Okay, now A is your reactant, that means A is your participating molecule. So the rate of the reaction will be proportional to the concentration of the participating molecule A. Now if you have the more reactants, not like just A, if you have many more reactants, then the rate of the reaction will be proportional to the product of those concentration of all the reactants. Now as you have seen, the rate is nothing but the change in concentration in time. So we can say that rate is change in concentration of the reactant by time, and if the reactant concentration is changing, that means the product concentration is also going to affect. So we can also say that rate is equal to change in concentration of the product by time as well. Now what is the change in concentration? So change in concentration is measured by the final concentration minus initial concentration. Now for this reaction, if the initial concentration of the reactant is AI, which I stands for initial, and final concentration is AF, F stands for final, and the product concentration initially was BI and final concentration of B is BF, then the change in concentration of A is AF minus AI, which is denoted by del A, and the change in concentration of B is similarly denoted as del B. Now when the reaction proceeds, what happens? The reactant gets converted into the product. That means with time the reactant species concentration is going to decrease and the concentration of the product is going to increase. So with time, what we can say that the final concentration of the reactant is going to be always less than the initial concentration of the reactant concentration, which is A here, right? And similarly the B final is always going to be more than the BI because the concentration is increasing always, right? Yes, so the delta A, which is nothing but my AF minus AI, is going to be a negative number because AF is less than AI, whereas the delta B is always going to be a positive number, right? So what we can say that a rate is the rate of disappearance of A because the reactant concentration is decreasing, and which is also equal to the rate of formation of B because the formation means the concentration of the product is increasing, right? Now to calculate the time change, we must say that the initial time is Ti and the final time is Tf, then the time required for this concentration change is del T, which is nothing but my Tf minus Ti. Now if we try to understand these chemical reactions graphically, then we see that rate is a positive number, correct? As we mentioned before, rate is always a positive number, but this delta A is my change in the reactant concentration, but it is a negative number because the reactant is going to decrease with time. So to balance out or to make this rate a positive number, we need to always put a negative sign when we write the rate in terms of any reactants, okay? Now the reactant concentration with time is going to decrease, as you also appreciate this. Now the time is increasing in this direction, and as you can see that the concentration is decreasing here linearly. Now the concentration can also decrease exponentially, okay? But which is what is much more interesting or worthy of note, that reactant concentration is going to decrease with time. Oppositely, the concentration of the product is going to increase. It can increase linearly, or it can increase exponentially, or it can increase in a logarithmic way, okay? But here also the point that you must note that the concentration of the product is going to increase, and here to write the rate in terms of product, as delta B is a positive number, then you don't need to put a positive sign or negative sign. It is always positive. When you write the rate of a reaction in terms of the appearance of product, then you should always put a positive sign. Now the two important concepts, average rate and instantaneous rate, you need to understand. Now consider these reactions where the reactant A is going to get converted into the product B, and if you see the delta T here from 0 to 1 second, the delta T is 1 unit because the time change is here is 1 unit, but the concentration change is from here to here, right here. Now this is denoted by delta A1. Now similarly, if we consider this time time change from 1 to 2 seconds or 1 to 2 unit, then delta t is going to be again 1, because 2 minus 1 is 1. But as you can see that then in this region the concentration change is very less, which is delta A2, which is less than the delta A1. That means if you write the rate of the reaction in this region, then it is going to be more than this region, because the delta A1 is higher than delta A2, correct? So what we can say that to write, and this is called the average rate, and to write the average rate we always need to provide the starting time and the final time. So to calculate the average rate we always need to provide that in between which time period you want to calculate the average rate, because if you calculate the average rate here in this time point, it is going to be different than that of this in this region. Now so you have seen that the average rate is my minus of delta A by delta T. Now if you start decreasing this delta T, you will see that delta T, if you decrease delta T, that concentration change is also going to decrease. So from delta T1 to delta T2 the concentration change has also decreased. Now to delta 3 it has decreased more, and after a certain time the delta T is tends to like a point. Okay, so then delta T is tends to 0, and then we can say the delta T is nothing but my dt. Similarly at that point delta concentration of A is tends to 0, and we can call it as dA. So we can calculate the rate at that point, so which is called the instantaneous rate, which is nothing but my minus of d of A by dt. So this is nothing but the slope of the curve at that point, which is denoted here by the blue dotted line. So the blue dotted line is the slope at this point of this graph, right? Yes. So this slope of this curve will determine the instantaneous rate at this point. So this is very similar for the product concentration as well. So rate in terms of appearance of B, we can say delta B or by delta T, and in this region, and this will be my average rate, whereas we can calculate the instantaneous rate by the slope of the curve at any point by dB by dt. So slope at this point is higher, and when the reaction goes towards completion, the slope of the curve decreases. Okay, so these are the instantaneous rate at this point, and initially this point. So how do we find the rate or speed of a reaction? Now we can find the rate or speed of a reaction by several ways. We can observe the change in the concentration of the reactants or products. Now we can also observe the change in the color. If a reactant is colorful but the product is not colorful, then you can see that the color is going to disappear with time. That means that the reaction is progressing. So you can monitor these reactions quantitatively using this UV visible spectroscopy. We can also observe the change in pH by titration. We can observe the change in volume. We can observe the change in pressure. And for chiral molecules, which is very interesting topic, and we are going to discuss in detail in our stereochemistry class, the change in rotation of plane polarized light by polarization measurement can also be done to find the rate or speed of a reaction. Now as we have already seen that the reaction concentration with time is going to decrease and the product concentration with time is going to increase. But after a certain time, if the reactant concentration does not reach to 0, but it reaches to a certain value, and it remains constant, and similarly the product concentration also remains constant, then this region is called equilibrium region. and this region is very interesting in thermodynamics. We'll talk about this region mainly in thermodynamics classes, and for kinetic classes this is the part where we are mainly interested. Now let us look at the process to write rate equations for a complex reaction. Now if we see that A is getting converted into 2B, so one A molecule is forming 2 B molecules. So initially if you have 5 A molecules and 0 B molecules, but after some time you lose X molecules, that is why you lose the molecules, that is why minus sign is put here. And so if you lose X molecules, so 2X molecules of B is going to be formed, because one molecule of A is responsible for forming 2 B molecules. So rate of the disappearance of A, we can say that minus dA by dt, and rate of appearance of B will be dB by dt. So dB by dt, what we can say that dB by dt is 2 into minus dA by dt, as you can see from here. Now you can put or take these 2 at this side, and you can write half dB dt is equal to minus dA dt. So this is my rate of the reaction. So rate equal to minus dA dt is equal to half dB dt. So if you notice this part carefully, so you will see that this minus sign is because of the reactant consumption, and here the sign is positive because the product is forming. Now the coefficient of this product is 2, so the coefficient is here, okay, like the coefficient becomes 1 by 2 here. Now if you try to write the rate of the reaction for this complex, like in 1A plus into B going to get converted into N3C and N4D, you can write the rate of a reaction is like minus 1 by N1 into dA dt. Minus sign is because of the reactants, and this N1 is the coefficient which comes as 1 by N1. Similarly for B, it comes as 1 by N2 and dV dt is there. For products, the sign is positive like here and here, and the concentration the coefficient is N3 and N4, so it comes as 1 by N3 dC dt and 1 by N4 dd dt. Okay, now we have learned many things how to write rate equations. So why this is important, you will see that this basic part is also important in these kind of exams. So this question is directly from your IIT 2002 and CBSE PMT 1997. So for the reaction H2 plus I2 getting converted into 2HI, the rate of the reaction. So rate, we know that these are my reactants, so we need to put minus signs. So del of H2 by del T, and here also the rate is del of I2 by del T, but here the coefficient is 2, so it will come as half and the positive sign, then the rate will be half del of Hi by del T. So the rate overally we can say that minus of del H2 by del T equal to minus of del I2 by del T equal to plus half del Hi by del T. So this was a option, an option. Okay, so now next question, if 3A is going to form 2B molecules, then the plus dB dt is equal to, now rate is equal to minus 1 by 3 dA dt, because the coefficient is 3 here, so it will come as 1 by 3, and this is my reactant, so you need to put a minus sign, right? Yes. So for products you need to put a positive sign, and the coefficient is 2 here, so it will come as 1 by 2 dB dt. Thus what we can say that minus 1 by 3 dA dt is equal to half dB by dt. So plus dB by dt is, you can just put this half this side, and so you will have this dB dt equal to minus 2 by 3 dA dt. Yes, so this is the answer. So I want you to solve this question by yourself and put the answer, what answer you got in the comment section. So the question is here. You can note it down and solve and comment below. So what we have discussed in today's lecture, we discussed the rate of a chemical reactions, different types of chemical reactions. We discussed about average and instantaneous rate and how to find them. And we also discussed how to write rate equations for like complex reactions in terms of concentration change of reactants or products. Also we solved some problems and there we have shown their solutions.
That's all for lecture 1. If you like this video, please like, share and do not forget to subscribe. Please do subscribe and hit the bell icon so that you don't miss our next videos on our next lecture series. Thank you.